At Fairgrounds St. Pete, we have a variety of touchless buttons, including infrared sensor triggered and ultrasonic sensor triggered. You can move your hand within proximity of a couple millimeter range, and then they trigger as if you pressed a button. Since there's no like physical contact with the buttons, they're kind of like this cavity, like a hole. And the idea is to hover your hand over that hole. The problem with a touchless button like that is you don't really have any kind of feedback. We needed to put some kind of lighting element so that you get a confirmation that you pressed the button. But the nice thing is once you set up a convention and you use it in one place, and if you repeat that pattern, then people learn it once and then they can apply it to other areas. We've even changed them out in the exhibits a few times. So the buttons that were in the opening are not the buttons that we have there today. So the designs changed over time based on what we call playtesting. So we would mock something up, usually in cardboard. We'd kind of put it in front of people and see, A, did they get it? B, can they use it? Is it reliable? Does it break? So we usually start with a breadboard, and then we wire it up to a sensor and connect that to a microcontroller, and we program it, and then we just try to figure out how we're using that sensor and get the kind of electronics right. For function, we went into CAD. We use Fusion 360. It's an Autodesk product, but we would model the sort of mounts and the holder of the button and the holder of the electronics, and we would print that with 3D filaments. So we'd use our own 3D printers here in the lab, and then we would kind of put them together and integrate other elements like the lighting as well.